In number 6, we are asked to use definition of I to solve an equation x square equals to -4. Okay, so here we have an equation x square equals to -4. What is the type of equation here? What type of equation is this? Not a linear. What is the highest power of variable? Our variable is x, right? And the x has a power 2. And if you have an equation with the highest power of variable 2, it's always quadratic. Linear has a power 1, okay? So if you have an equation with a variable having power 1, it's linear. But here x has a power 2. This is the quadratic equation we are asked to solve. Solve means we have to make our x by itself. Now, along with x, we have a square on the left side, and let's get rid of a square from left side. So if we want to get rid of a square from the left side, we get positive or negative square root of whatever we have on the right side, that is -4. Okay, so there is nothing to get rid of from x other than power 2. Okay, and if that is the case, then we always get positive, negative, and square root, and whatever you have on the right side, it is under the square root. Okay, now here this is positive, negative. Now square root of -4, if you use calculator, you will get error. So this is not a real number, right? So we have a negative number under the square root. So this is the, what type of number is this? Imaginary number or a complex number. Okay, now we know how to solve imaginary number. So we can't have negative under the radical sign. We have to rewrite this number. Okay, so how do we rewrite? For negative, what we use? We replace negative by I squared times 4, or -4 is -1 times +4, and -1 is I squared. Okay, so this is positive, negative, square root of I, that is I, square root of 4, that is 2. So our two solution for this equation is positive 2i and negative 2i. So this equation, it does not have a real solution, but it does have a complex solution. Our solution is a complex number. Okay, so positive 2i and negative 2i, these are the two solutions for this quadratic equation, which are complex solution, not a real number. Okay, so whenever you are solving a quadratic equation, it's not we always get a real number as a solution. We might get a complex number as a solution for the equation. Okay, now if you see these two solutions, so we have a 2i and negative 2i. What kind of complex number are these? So we have a positive 2i and we have a negative 2i. What do we call these two complex numbers? They are the conjugate of each other. Okay, so if we have a one complex number as a solution, then its conjugate is also a solution. Okay, for example, just let's say we have a complex number 1 plus 3i, and this is a solution for some quadratic equation. Now, if you know one complex number as a solution of a quadratic equation, then its conjugate will also be a solution. Okay, so if 1 plus 3i is a one complex solution for some quadratic equation, then what is its next solution? Its next solution is 1 minus 3i, its conjugate. Okay, you flip the sign of I term. We have a positive 3i, make it negative. So 1 minus 3i is also solution for the same quadratic equation. Okay, so once you have the idea of one complex solution, you are not required to find the other. Just write down its conjugate. It's always a solution. Okay, now let's go to number 7. Now here we still have a quadratic equation, and now here we don't have a specific method here. Okay, so you are allowed to use squaring method, completing the square method, factorization, or quadratic formula. And if you do not have a specific method, then just use the quadratic formula. That should be the easier one, right? Now, in order to use the quadratic formula, what we have to do first step, we have to rewrite our equation in a standard form. So standard form is we must have a 0 in one side, and we have to rewrite every term in the descending order of exponent of the variable. So we compare this quadratic equation with our standard equation ax square plus bx plus c equals to 0. This is our standard equation. We compare and we find a, b, c. So what is our a? A is -3. What is b? B is +2. What is c? -4. Now let's substitute this a, b, c in our quadratic formula. Variable is x and our formula is -b plus or minus square root of b square minus 4ac divided by 2 times a. Now you replace your a, b, c with their values. So we have negative. Our b is +2, so we have -2 plus or minus b square, that is 2 square, minus 4 times a, which is -3. Make sure to have parentheses, times c, which is -4, divided by 2 times a, which is -3. Now this is -2 plus or minus, let's simplify under the radical sign, 2 square, that is 4. -4 times -3, that is +12, times -4. What is that? -48, right? Divided by 2 times -3, that is -6. Now this is -2 plus or minus. So it's 4 minus 48, that is -44 divided by -6. Now, what type of number we have under the radical square root? Negative. It means what kind of solution we will get here? We get a complex solution, okay? And we can't have, okay, we have to rewrite. If you see negative number under the square root, we always need to rewrite this, okay? So let's go ahead and rewrite that expression. So we have -2 as it is, positive, negative. Now how we rewrite? So we replace negative by I square, right? So our negative is I square. And you can also simplify 44. We can rewrite 44 as a 4 times 11, right? Divided by -6. This is equals to -2 plus or minus. Now let's find the square root of I square and the square root of 4. So square root of I square, that is I. Square root of 4 is, that is 2. So let me write 2 in front. So 2i times the square root of 11 is square root of 11, right? Divided by -6. Okay. Now you just take positive first, then you take the negative. So let's take positive. So we have -2 positive 2i times square root of 11 divided by -6. And the next -2. Now instead of positive, you take -2i square root of 11 divided by -6. So these two are the complex solution for the quadratic equation. And do you see these two are the conjugate or not? Are these two complex number conjugate of each other? Yes, right? Everything is same. The only difference is that in one complex number we have I term positive. In the second complex number, our I term is negative. Okay, so every time if you have a complex number as a solution, the conjugate is always the another solution. Okay, all right. Any question up to here? Now let's go ahead and solve more equation, which is our next section, section 1.4. So in 1.4, we have a rational equation and we have a radical equations. So we'll try to solve equation. We will try to find the value of variable. Okay. Now here we have this equation. 3x to the power 4 plus 5x squared minus 2 equals to 0. And solve the equation for all real values of x. Now, what is the type of equation? Or what is the degree for this equation here? So degree means you are always looking at the highest power of variable. So what is the highest power of a variable do we see here? 4, and that 4 is the degree for this equation. Okay, if degree is 4, then we can find at least 4 solution. Okay, so this equation will have at least 4 solution. Okay, that's what we know. Now if you have, or if you see the equation with a degree 4, then we have to rewrite this equation in a quadratic form. Okay, and the reason here is that we know how to solve quadratic, right? We have a factoring method, we have a completing the square method, we have the quadratic formula. Okay, so every time if you see an equation with a degree 4, we have to rewrite this equation in a quadratic form. And to rewrite that, okay, so before that, so here to rewrite that, so this is 3. Now can we rewrite x to the power 4 as a square of x square? Is it same? So we have 3 as it is. We are trying to rewrite this equation in a quadratic form. Okay, so we have x to the power 4, and x to the power 4 is same as square of x square, right? Okay, plus we have 5x square as it is, negative 2 equals to 0. Now let's replace our every x square by some different variable. So let me call it a. So let's call our x square is a. Okay, so for every x square you can pick any variable. Let's replace by a. Now our equation become 3 times. So for this x square we have a, and do not forget about this square. So we have 3a square plus 5. This x square is a, 5a minus 2 equals to 0. Okay, since we have a in our quadratic formula, just let me pick different variable. Okay, let me pick t. Okay, but it's okay if you use a, but we might get confused with a in the quadratic formula. So instead of a, let me make it t. So let's call our x square is t. So we have 3t square plus 5t minus 2 equals to 0. Any question up to here? Now, what type of equation we have here? 3t square plus 5t minus 2 equals to 0 is? What type of equation? It's a quadratic equation, right? And let's use quadratic formula here. Okay, to use quadratic formula, we have to find a, b, c. So let's compare this with ax square plus bx plus c equals to 0. Since we already have 0 in one side, so we can skip that. So our a is positive 3, b is positive 5, c is negative 2. Okay, our variable is t. So we have t in our formula. So we have t equals to negative b plus minus b square minus 4ac divided by 2a. Okay, any question up to here? We had an equation with a degree 4. Okay, we rewrite that equation in terms of quadratic equation by replacing x square by some variable. Okay, and once we have our quadratic equation, we find abc. Now let's substitute abc in our quadratic formula. So negative b, we have negative b is 5 plus or minus b square, that is 5 square, minus 4, a is 3 times c is negative 2. Make sure to have parentheses for negative number, divided by 2 times a, which is 3. Now let's simplify. We have negative 5 plus or minus 5 square, that is 25. Negative 4 times 3, negative 12 times negative 2, that is positive 24, divided by 2 times 3 is 6. This is negative 5 plus or minus square root of 49 divided by 6. Okay, so just stop me, okay, if you have any question. Now this is negative 5 plus or minus square root of 49, that is 7 divided by 6. Now we take positive, negative 5, so we take positive 7 divided by 6. And the next we take negative 7, negative 5, negative 7 divided by 6. So this is positive 2 divided by 6. This is negative 12 divided by 6. We can simplify. This is 1/3 and next is negative 2. Bless you. So this is t. So our t has a two value. One is 1/3 and next is negative 2. Now, are we trying to find the value of t in this equation? What is our target? We are trying to find the value of, or we are trying to solve an equation with a variable x, right? So our target is finding value of x. We have our t, which is 1/3. So we have two values for t, 1/3 and negative 2. Okay, but we are trying to find the value of x. Now, how t and x are related? So what do we know about that? So the very first thing, so like in the here, what we know here is that our x square is equals to t, right? That's what we had assumption at the very first. Now let's replace our t by this number. So we have x square equals to t. So we have x square. Let me take 1t first, 1/3. And if we take negative 2, our equation is x square equals to negative 2. Okay. Do you have a question? Now we are not done yet. We are solving our x. We have to make x by itself, but these x have a square here. We need to get rid of this square. And when you get rid of square from x, we get positive or negative square root. And whatever you have on the right side, it's under the radical sign. And you do the same thing for the next equation. X equals to positive, negative, square root of negative 2. Now we are almost done here. So this is positive, negative, square root of 1, that is 1. And square root of 3 is, let's write as a square root of 3. Next we have x equals to positive or negative. Now we have a negative under the radical sign. And how do we get rid of that? This is, we replaced it by I square, right? So we have I square for negative and times 2. This is square root of I square is I times square root of 2. Okay. Now how many solutions do you see here? Do you see 4 solutions? So let's make a list here. So the very first solution, you take positive. So positive 1 over root 3. Second solution is you take negative, negative 1 over root 3. From here, we have positive I times root 2 and negative I times root 2. So we had an equation with a degree 4. And this equation has exactly 4 solutions. And out of these 4 solutions, how many solutions do we have as a real numbers? Out of these 4, which are real numbers? The very first 2 solutions, right? So first 2 solutions are the real solution for this quadratic, not the quadratic, for this an equation. Now next 2 solutions, these are the complex solution. And these 2 are also conjugate of each other. Okay, so we have a I times root 2, and the next one is negative I times root 2. These 2 are conjugate of each other. We are asked to find the real solution, and these 2 are real solutions. Okay, any question? So once you have the idea of using quadratic formula, you should be good. The only new thing here, what we did here is that we rewrite our equation with a degree 4 in the form of in quadratic form, okay, by replacing our x squared term by some new variable. Okay, okay, can we start next example? Okay, now let's see what we have next here. Okay, very similar. We have the equation with a degree 4, x to the power 4 minus 49 equals to 0, and the very similar method. Now we rewrite this equation in a quadratic form. So we can rewrite our x to the power 4 as a square of x square. So our x to the power 4 is a square of x square. Then we have negative 49 as it is equals to 0. Now we replace this x square by some new variable. So let's call it, so we call t, now let's call it p. I mean, you can just call any variable, okay? So let's call our x square is p. If x square is p, then our equation is, so for this x square, we have p, and do not forget about this square. So we have p square minus 49 equals to 0. So we replace, we rewrite our equation in a quadratic form. So p square minus 49, this is quadratic form. Now let's solve this quadratic equation. You can add 49 on both sides. And this is p square, this is 0 equals to 49. We are solving for p in this case. And the only one thing that we need to get rid from p is square. And when we get rid of square from p, we get positive or negative square root of 49. Okay. Now we know our square root of 49 is 7. So p is positive 7 or negative 7. So p has a two value, positive 7 or negative 7. Our target is finding the value of x, and our x and p are related this way. So let's rewrite this. Our x square is equals to, let's take positive 7, which is p, and in next we have x square equals to negative 7. So we get two quadratic equation. So we need to get rid of a square. For that we get positive negative square root of 7. And here you do the same thing. You get rid of a square and you get positive negative square root of negative 7. So from here our solution is positive 7 or negative 7. Now here we have a negative under the radical sign. Okay. We have to rewrite. Okay, every time if you have a negative under the square root, let's rewrite this. So this is positive negative, and replace negative by I square and 7. So this is, we know the square root of I square, that is I times square root of 7. So the next solution is positive I times root 7, negative I times root 7. So this way our equation has four solutions. Out of these four solutions, we have two complex solutions and two real numbers solutions. So you will get a very similar equation on your exam. Okay, you will see one equation with exponent 4. Okay, and if you have an equation with an exponent 4, you have to rewrite in a quadratic form. And once you have in a quadratic form, use the quadratic formula. Okay, the remaining is simplification. Okay, does anyone have question? All right, now let's go to the next example. Now in next example, what is the type of equation do you see? What type of equation is that? So what we have 4 over 3x equals to 2 over x plus 2 over 3. Now what is the type of equation? So till now, the very first 1.1 we talk about the linear equation, right? So linear equation has the variable with a power 1. Okay, if we have an equation with a power 1, it is a linear. Then we had a quadratic equation. If we have the variable with a power 2, then it's a quadratic equation. Now, in this example, what is the power of x? Is it 1 or is it 2? What do you think? So if you write your x in a numerator, okay, or okay, now the easiest way to find the type of this equation here is that, so our variable is x, right? Do you all agree with this one? And our variable is in the new denominator, right? And if we have a variable in the denominator, then that equation is a rational equation. Okay, so this is our rational equation. Now, if you want to find the degree of x here is not 1. So here we can rewrite, you are not required to write this one, but just I want to show you here. So we can rewrite this as a 4/3, and I can rewrite x in the numerator. When I write x in the numerator, I have to switch the sign of a power. So this will be x to the power -1 equals to 2 times, if you want to write x in the numerator, you have to switch the power of x. We have positive here, make it negative, plus 2/3. Now here, the variable x has a power -1. To be linear, we must have a +1, but it's negative. Okay, so the easiest way to identify here is that if you have a variable and it's in the denominator, it's a rational equation. Okay, or this is a fraction, right? We have a 3 fraction. That's the easiest way. Excuse me. So we have a 3 fraction, 4/3x, 2/x, 2/3. Now our target is solving here. Now before we solve this rational equation, we have to simplify on a both side. Okay, or we can find the common denominator. So when we have a fraction and when we are adding or subtracting fraction, we always need to have the common denominator. Okay, without common denominator, there is no way we could add or subtract fraction. Now here, let's make a list of denominators. So we have a 3 denominators. So we have a 3x, right? First denominator. We have a x, second denominator. We have a 3. So we have a 3 denominator from each fraction. Now our target is to find a common expression. Okay, common expression that is divisible by 3x, that is divisible by x, and that is divisible by 3. Now, can you think of an expression that is divisible by 3x, that is divisible by x, and that is divisible by 3? Okay, let's take 3x. Now, is 3x divisible by 3x? 3x divided by 3x is 1. Is 3x divided by x? 3x divided by x is 3. Is 3x divided by 3? 3x divided by 3 is x. That's right. So 3x is the expression which is divisible by each denominator here. Okay. So now that is our common denominator here. So our common denominator is 3x. So finding common denominator means you are finding a number or you are finding an expression that is divisible by each denominator. Okay, now once you have the common denominator, we multiply each expression on this equation by common denominator. So let me write our equation. So our equation is 4/3x equals to 2/x plus 2/3. So we have these 3 expressions. We already know what is common denominator. Once we have the common denominator, we use this common denominator to multiply each expression on a both sides. So let's multiply both sides by 3x. Let's multiply each expression, okay, not only one. So you multiply each expression by 3x. You multiply each expression by that common denominator. You can't pick any expression, okay? You have to pick an expression at first which is divisible by each denominator, which we call common denominator. Once you have the common denominator, multiply each expression by that common denominator. That is the very first step of solving rational equation. Okay, any question? Find the common denominator, use that common denominator to multiply every expression on that equation. Okay, now let's see. So we have, okay, now we have 4 times 3x divided by 3x. Can we cancel 3x and 3x? Yes. So can we cancel x and x? To cancel, you must have your expression in a product form in the numerator, and you must have expression in a product form in the denominator. Okay, we do not have plus or minus in the numerator and denominator. We have product form, so we can cancel. See, like in between 4 and 3x, we have a product. So, and we have a 3x, only one here. That's why we can cancel. So here we have 2 times 3 times x. So everything is in a product form. So we can cancel x and x. On the right side, we have, bless you, 3 and 3 is cancelled. Our numerator is 2 times 3 times x. It is in a product form. Okay, and we are dividing by that 3. We have a common factor, so we cancel 3. Now let's rewrite this equation. So we have a 4 left equals to 2 times 3, that is 6, plus 2 times x, that is 2x. Now what is type of equation? What type of equation is this now? We have a linear equation, right? We know how to solve linear equation. So let's collect the like terms, get rid of 6. So this is 0. 4 minus 6 minus 2 equals to positive 2x. Now let's divide both sides by 2. Negative 1 equals to x. So our x is negative 1 and is the solution for this rational equation. So you have, okay, now like once you practice very similar, you will have an idea how to solve. Okay, so whenever you have to identify at first what type of equation is given to you, and based on that type of equation there are the different methods. Okay, so this is the rational equation, and if you see rational equation, the very first thing is finding a common denominator. Finding a common denominator means we are finding an expression that is divisible by each denominator. Once you have a common denominator, you use that common denominator to multiply every expression on that equation on a both side, and after that simplification. Okay, any question on this example? Okay, now let's go to the next one. So here we have, what type of equation is this? Rational. We have our variable x in the denominator, so this is the rational equation. Now first step is finding a common denominator. So we have a 3 denominators. Just let me make a list of that. So our first denominator is 2x minus 4. Second denominator is x square minus 4. And third, okay, just let me have a space here. So first denominator we have 2x minus 4. Second denominator x square minus 4. Third denominator x plus 2. So we have 3 denominator. Now as like the previous example, can you think of an expression that is divisible by each of these denominator? Is it easier for you? X plus 2. Is x plus 2 divisible by 2x minus 4? What is the so okay, let's see. So if it's x plus 2, so if you divide x plus 2 by 2x minus 4, what do we get here? You have to, there should not be any denominator if you are dividing, right? So we can't, I mean, we still have the denominator. There is no way we could divide. Can you think of expression that has to be divisible by each of this denominator? Now if it's not easy, here's the way to find common denominator. Okay, to find the common denominator, we just write down every denominator, and the next step we factorize. We factorize, or we rewrite each denominator in a simple factor form. Okay, now let's factorize this 2x minus 4. What is the first step of factorization? We look for the common factor in each term. Now we have a two term, 2x minus 4. Do you see any common factor in this two term? Do you see 2 as a common? Okay, now let's factor out 2. So we have a 2 as a common factor, and now we divide each term by 2. 2x divided by 2, that is x. Negative 4 divided by 2, that is negative 2. So factorization is very important for this chapter, okay? You have to know the factorization. And the very first step of factorization is looking for common factor in each term. Okay, now we have x minus 2, and this is already in a simplest factor form. Okay, so the variable x has a degree 1, and if we have an expression with a degree with a power of a variable 1, then it's in a simplest form. So we are done here. Now let's go to the next denominator, which is x squared minus 4. Now, how do we factorize x squared minus 4? So we have our two terms, right? The first step, do we have any common factor in each term? Do we have any common factor in x squared and negative 4, like we had in the first denominator? Do we have, other than positive 1 and negative 1, do we have any other number as a common? No. Okay. Now the next, since we have a two term, now if we have a two term, there is always three ways to factorize. We always check whether those two terms is a difference of square, sum of cube, or difference of cube. Now which one is this? Is this the sum of cube, difference of cube, or difference of square? Can we rewrite this as a difference of square? So here we have x squared, right? We already have a square here for x. Now how can we rewrite 4 in a square form? 2 square, right? So 4 is 2 square. Now if you have difference of square, then our factors is sum of those two numbers times difference of those two numbers. So here our a, what is a? A is x, b is 2. So we replace a by x and b by 2. So that is x plus 2 times x minus 2. Now each factor has a x with a power 1. So this is in the simplest form. Okay, so we are done with factorization for second denominator. Now we have the third denominator. Now in the third denominator, what is the degree of x in third denominator? So we are talking of this denominator, okay, x plus 2. What is the power of x in this expression? 1, right? So it is already in a simplest form. So we take x plus 2 as a factor, like itself. Like for example, if we have a 7, then 7 itself is a factor of 7, right? Finding factor means we are finding a number that is divisible to 7. So 7 divided by 7 is 1. So it's already in the simplest form. So x plus 2 is factor for itself. Okay, any question in the factorization? You should know factorization, okay? Without factorization, this chapter will be very tough. Okay, so we did review on factorization, and if you still need help with factorization, please let me know. Okay, this is the most important part that you have to know. Okay, so our target is finding common denominator. Now, once you factorize each denominator, now let's find common denominator. To find common denominator, we look the common factor in each denominator. Now, do we have a common factor in every denominator? We have a 3 denominator. Do we have any common factor in all of these 3 denominators? Do you see common factor? Do you have a exactly same factor in each of these 3 denominators? We don't have, right? Now, if we don't have, now, do we have any common factor in at least 2 denominators? If we take first denominator and second denominator, we have x minus 2 as a common factor, right? So if you have a common factor in at least 2 denominator, write that common factor once. Write down only once. Okay? If you have a common, then just write it only one time. Now, if we look at second and third denominator, do we have common factor? And what is that common factor? X plus 2. So we have x plus 2 and x plus 2 here. It's common, and you are writing only once, x plus 2. Now the last step, we look for the remaining factor which is not common. Now what factor is not common here, and what is that remaining factor? 2, right? So we have one more factor, 2, that is not common with any other denominator, and you write that 2 as well. And just let me write that 2 in front, okay? You can just write at the end 2, it doesn't matter. All are in a product form, okay? So this is how we find the common denominator. So this is the expression divisible by each of these 3 denominator. First step, factorize each denominator. Second step, you look for the common factor. And if you have a common factor, you write once, okay? So write down every common factor in all denominator once, and once you have that, you have to rewrite every remaining factor which is not common, okay? So here 2 is remaining, and you must have that 2. So this is our common denominator. Now once we have a common denominator, what is our next step? We multiply each expression by this common denominator. Now let's go ahead and multiply each expression by common denominator. Our first expression is x minus 3 divided by. Now can I rewrite 2x minus 4 as a 2 times x minus 4? Do you all agree? That's what we had, right? Okay, now let's multiply this by our common denominator. Common denominator is 2 times x minus 2 times x plus 2. Now plus second expression, so our second expression is 1 divided by, okay, just let me rewrite this here, but everything is same, okay? So we have x minus 3 divided by 2 times x minus 2, and our common denominator is 2 times x minus 2 times x plus 2, plus we have second expression 1 divided by x square minus 4. And how can we rewrite x square minus 4 in a factor form? That is x plus 2 times x minus 2. You multiply this with a common denominator, which is 2 times x minus 2 times x plus 2. Okay, now that we have equals to, then we have one more expression, that is 1 over x plus 2. Multiply this by a common denominator, 2 times x minus 2 times x plus 2. Okay, it looks a lot here, but once you have idea of factorization, once you have idea of how to find common denominator, then you are using that common denominator to multiply each expression on a both side. Okay, any question? Now we simplify here. To simplify, so just let's call this is one term, so that and every term in the numerator and denominator is in a product form. Now we can look for the common factor in the numerator and denominator and cancel. Okay, so we have 2 common cancel, x minus 2 common cancel, then x plus 2 cancel, x minus 2 cancel, x plus 2 cancel. But before you cancel, make sure your numerator and denominator is in a product form. Okay, it has to be in a factor form. Now let's rewrite the remaining expression. So we have x minus 3 remaining times x minus 2 remaining, x plus 2, plus we have 1 times 2 remaining. On the right side we have 1 times 2 times x minus 2. Once you cancel the common factor in the numerator and from numerator and denominator, you rewrite the expression left here. Okay, now we are not done. We are trying to solve for x, right? We have to make our x by itself in one side. We have so many x here. So let's get rid of parentheses, look for the like terms, collect x term together and constant together and find the x. Okay, now here we have a binomial. This is x minus 3. So here we have a binomial times binomial. So this is binomial, 2 terms. This is binomial. And what are we doing? We are multiplying, right? Now let's use a FOIL. So x times x, that is x square. Outside term x times positive 2, that is positive 2x. Let's multiply inside term, negative 3 times positive x, negative 3x. Let's multiply last terms, negative 3 times positive 2, negative 6, plus 1 times 2 is 2 equals 2. So we are simplifying here. So 1 times 2 is 2. Now 2 times x is 2x. 2 times negative 2 is negative 4. Let me know if you have question. You get rid of parentheses, you distribute, okay. Now we look for the like terms. So this and this is like terms, negative 6, positive 2 like terms. So here, so we have x square, positive 2x, negative 3x, that is negative x, negative 6, positive 2, that is negative 4, equals to, we have 2x minus 4. Now, at this point, we all know the type of equation. What type of equation is this? What is the highest power of x? 2. And it is a quadratic equation. So to solve quadratic equation, you can use quadratic formula, factorization, or computing square method. So let's rewrite in a standard form. Rewriting in a standard form means making 0 on one side. So let's subtract 2x on both side and add 4 on both side, so that we have 0 on the right side. So this is x square, negative x, negative 2x, negative 3x. This is 0 equals to 0. So if you have a quadratic equation, always make the 0 in one side. Now let's use a factorization. It's going to be easy. If we want to use a factorization, we have to factorize the left side, and our x is a common factor. So let's factor out x. If you factor out x from x square, we have x. If you factor out x from negative 3x, we have negative 3 equals to 0. You factorize left side. Now once you factorize, the very final step and the easy step is we set each factor equals to 0. So we have two factors, x and x minus 3. So we set first factor equals to 0. We set second factor equals to 0. Now we have the linear equation now. So we already know x is 0 from here, and from here you add 3 on both sides, we get x equals to 3. So 0, 3 are the solution for this rational equation, but we have to verify, okay. Now to check, if you substitute, if you replace your x by 0 and 3 on this equation, is there any way we could get 0 in the denominator? Like we have a two solution, 0 and 3. Now out of these two solution, does this number make 0 in the denominator? Like if you replace your x by 0 first, then 3, do we get 0? So if you take 0 and 2 times 0 minus 4, that is negative 4, we have a negative 4, we have a positive 2, so it's not 0. And if you take 3, it's not 0, okay. But if you have a value of x that make denominator equals to 0, then that x is not a solution. But in this case, both of these are solution for this rational equation.